Hello viewers, welcome to ENC Digital class. Myself Rasmita, Jena, lecturer in computer science. So in today's class we will be discuss an important topic of database management system, that is your indexing. That means we have already discussed about how by using searching the maximum time required and what is the IO cost, and in this class we will be discuss about indexing. That means by using indexing how you will be minimize the IO cost as well as the time required to search a particular record. So first we have to know about what is indexing. Actually indexing is what, whenever we are using indexing, it will optimize the performance of database by minimizing the access those are required when we execute a query. So let us define me what is indexing. Means it is used to optimize the performance of database by minimizing number of access when the query is processed. Okay, that is indexing. That means it will optimize the performance of database by minimizing the number of access required when the query is optimized. Okay, that means when we are executing a query, the query required those time can be optimized or the IO cost can be optimized if we are using indexing instead of searching. Actually indexing is what? Indexing contain two field. Okay, indexing content two field. One is your pointer and second one is your key field. Okay, so key field means this is the key field of the record, and from this key field we will be point to the record which is stored in the hard disk of the computer system. Okay, and this indexing is of different order, that may be your order. That means when you are using indexing, the data records are in order, that means they are stored order in hard disk, or they may stored in non-order format or on order format, and it is basically divided into three categories, that is primary index, clustering index and secondary index. So it is of three types. That means indexing is of three types. One is a primary index, then second one is a clustered index, and last one is a secondary index. Okay, let us see. This is the table. You must remember this table for accessing all the indexing operations. That means I already told about the records those are stored in the hard disk. When we are using indexing, in that case the records are maybe in order or in non-order. Okay, and in some cases we may need the key field, and in some other cases we may not need the key field, non-key field. Okay, so order key field means in primary index it needs the file must be ordered and need a key field to search a particular record by using indexing. Okay, in primary index. And in clustering index the file must be in order, that is the data those are stored in the hard disk that must stored in a order, and it does not need in key field to search a particular record. That means the clustering index is based on the non-key field. Then comes to secondary index, that is the third category of the indexing. In secondary index there is two cases. In one cases it needs file should be in non-order, that means the file may be in on order and it required a key field in the records of the data. And also there is another case, the files are in on order as well as it does not need any key to access the records in the database. Okay. So, let us discuss the first one, that is primary index. So, first we will be discuss about primary index. The primary index based on the ordered key field. Okay. And in primary index it must satisfy two conditions. Okay. First condition is, you know that in primary index the record those are stored in the hard disk, that must be ordered and there must be a key field. Okay, these are the two conditions that must satisfy by the records where we want to apply the primary index. So, first condition is the records those are stored in the hard disk must be in ordered. Okay. And second condition is there must be a key field. There must be a key field. Okay. So, let us take one example from primary index. So, take an example of student records. In student's record, suppose the record containing data, student role, student name and suppose age of the student. And in student table, roll number is the key field. That means by using roll number we can search a particular student information. Okay. So, this is one example of primary index. That means when you are taking example of student records, so in this case role is the key field and based on this key field we can apply the primary index. We can also take another example, that Indian Railway, suppose you want to search a particular train. If you search a train by the name of the train, that may be a duplication of data. But if you search by the number of the train, then you can get the unique information. And in SQL, when we are executing a student record, and in that case declare the roll number as the primary key, and when you declare the primary key of the particular table, then it automatically sets that primary key as the primary index of that record. So, this is about primary index, and the primary index is of two types, that is dense and sparse. Okay. Primary index is of two types, that is dense and sparse. Okay. So, before we go for the types of the primary index, let me define how the primary index is executed. So, in primary index, suppose this is our head disk. In head disk, suppose the data are stored, suppose this is role, name, age and address. Okay. This is the student roll 1, 2, 3, 4 like this, the name of the student. Suppose age of the student and this is the address. Okay. And then we have to know about how the index field is represented. We know that index field has two parts. One is a pointer which point to the hard disk where the record is located, and second one is the key field. As I already told about, say the primary key of the table is the primary index of that table. Suppose consider in this case here role is the primary key for the student table. So, we can take role as the key field for the index table. And in primary index what is exactly happen? Suppose the key field is 1, 2, 3, 4 like this. That means it indicates this record 1, that means roll number 1 student will point by this pointer. Okay. That means this is divided into number of blocks. We know that head disk is divided into number of blocks, and in this number of blocks we will store our data. So, record 1 point to its record which is present in the hard disk, then record 2 point to next record, record 3 point to next record and record 4 point to next record. So, like this is the primary index representation in memory. Then the primary index can represented in two ways, that is in dense or sparse. Okay. What is the difference between these two? In case of dense, that means every record is pointed by one pointer to its corresponding record which is present at the hard disk. That means we can define dense record means the number of block in index is equals to number of record in the hard disk. That is your dense primary index. Okay, you can see here the number of record is pointed by number of block which are present in the index table. So, that is your dense index. So, next we will discuss about what is parse index. In parse index, we can take one pointer for the number of records. Okay? Then how it will be executed? Let us see the difference between dense and parse. So, in dense index has an index entry for every source key value in the data file. That means, suppose we have the hard disk, and in the hard disk the record are stored block wise. Suppose the record contain role, name, age and suppose address. Okay. That means in case of dense index, it will contain a pointer for every source key value which is present in the data file, and we know that the index file has two parts. One is your pointer part and another one is your key field, and in this case suppose key field is role, and for every source record there is a pointer to the hard disk. That means suppose we want to search, suppose the records are role 1 name is A, suppose age is 15, address is CTC, role 2 having name B, like this. So, these are the records, and in this way we have number of records in the hard disk. That means every pointer, that means every source key value points to every record, or every source key value is pointed by a pointer in dense index. That means 1 will point by one pointer, and 2 roll number will point by its next pointer, 3 is point by its next pointer. Okay, this is your dense index. And what is parse index? In case of parse index, it has the index entries for only some of the search key value. That means suppose this is our hard disk, okay, and hard disk containing data, suppose role, name, age and address, and this is the block, and we know that in hard disk data are present in block wise. Suppose these are the roll numbers, this is the name of the students, okay, and this is the age, okay, like this is the address, and we can write, okay. And in sparse index has index entries for only some of the search value. That means the index table is designed like, we know that is two pointer, that is two field, one is the pointer and one is the key field. In key field it will written like this 1, 2, 3, 4 and next 5, 6, 7, 8. That means if we want to search the record number 2, then the record will point by this block 1. Okay, that means this pointer is point to block 1, this pointer is point to block 2. That means for searching a particular number that is present from 1 to 4, we will have one pointer. Okay, that means in this case we have index entries for only some of the search value. Suppose we want to search a particular record having roll 6, then this will be point by this pointer, that means this will point to block 2. Suppose we want to search record number 7, so in this case also it point by the pointer to block 2. So this is the difference between index and parse. Okay, and in primary index is a dense index or sparse index. The primary index is usually sparse in nature, because if we maintain dense index in primary index, then it will require number of pointer for every search key value, which is more difficult to manage the number of pointers by using primary index. So use the sparse index in case of primary index, because in sparse index we know that this index has an index entry for only some search values. Okay. So, this is the difference between days and parse. Comes to complexity required for the primary index, that is log n base 2 plus 1. Okay. Log n means here the n represent the number of block in index file. Okay. And 1, this plus 1 means when the pointer point to the hard disk, it will take the time to search that record, that is plus 1. Okay. This is the time complexity required for primary index. So, next we will see the clustering index. You can see the clustering index is based on the concept of the file must be in order and it does not require any key field, that means it is based on the non-key field. So, let us see what is clustering index. So, clustering index is what? In clustering index, it requires two conditions. The first condition is the records or data, those are stored in the hard disk must be ordered. Okay. And the second condition is it is based on non-key field. Okay. So, let us see the example of the clustering index. In clustering index, suppose there is a department table having attribute department number, suppose student, and suppose the subject. Okay. This is your hard disk file and next one is your index file, the clustering index file. As we know that it contains two fields, one is your pointer field and another one is your key field. Okay. In hard disk, data are stored in the block wise and these are the department number and name of the student. Okay. And this is the suppose subject, like this. In clustering field, the data those are stored in the hard disk must be ordered. You can see the data are in order, that means 1, 2, 3, 4 like this, and in second it is based on the non-key field. Text file contain the key field, the department numbers are the key field, and suppose we want to search the student information, those are present in department 1. So, this is pointed by this pointer. Okay. And suppose again we want to search the student informations, those are present in the department 2. So, this will also point by this pointer. Okay. That means these two pointers are present in one block. And suppose we want to search the student information of department number 3. So, this is point by this, and you can see there is a difference. The department 3 is present in 2 block, and in this case the search is going on like the search starts from this block and it will be processed to next block. And how it will be processed to next block? In this case we have a new concept, that is block anchor. Okay. Its block anchor means you can see the department 3 is stored in the block 2 and it will process to block 3 and the search will continue by using this block anchor. Okay. This is about clustering index. Okay. And in clustering index, what is the time complexity required? The time complexity required, that is log n base 2 plus 1 because you know that log n base 2 in primary index, it is the number of block in our index file. That means the number of block those are present in the index file, that will be calculated by log n. And this one is what? This is point to the hard disk, that means the pointer point to the hard disk, and in the hard disk the searching time required to search a particular record, that is plus 1. plus 1. We can see in some cases the record may be split to the next block. By using block anchor, we can search those records. That means the department 3 student information may be searched in block 2 and that may proceed to block 3. So, in this case, if the number of anchor proceed one by one, you can add plus 1 like this. So, this is the time complexity required for clustering index. So, this is all about your primary index and clustering index. And one thing, in clustering index also it is based on the sparse index. Okay, because if we use the dense index, then it is difficult to manage the number of pointers by using dense index. This is all about your primary index and cluster index. So, in next class we will be discuss about secondary index. Thank you. Keep watching.